Hey guys, this is your day 4 assignment that I have in front of me right here. It's all about quadrilaterals, and you're going to need to use the properties of quadrilaterals and apply those properties in order to answer some of these questions. So if you were in class, you should have gotten a handout that had properties of quadrilaterals on it, and it maybe have looked something like this. Okay, now the one I handed out in class, it didn't have all the bullet points. It had the circles, but it didn't have all the bullet points. If you want to print one of these out, you can. There's a copy of this in the assignment description. It should be linked. It doesn't have all the pictures in it, so in a previous video I went through and I drew a lot of these pictures just to show you kind of how to draw the shapes and to help you visualize like what some of these properties mean, and these pictures actually may help you. So I'm going to refer to this in this worksheet, but again, if you either missed class today or you were in class and you want to fill in some of these, you can actually go in and watch that other video, and you can print out this handout. The one I handed out in class also had another side with all the properties listed, so you kind of have them there anyway, but hopefully that will help. All right, so let's take a look at some of these problems, okay? First off, we just got to identify the shape and start identifying some of its properties. Okay, so for parallelograms, first thing I know, opposite sides are parallel. Okay, so these are parallel, these are parallel. The other thing I know is that opposite sides are congruent. So this side's congruent to this side, and this side is congruent to this side. Okay, I know that the diagonals bisect each other. This is a diagonal, and this is a diagonal. So while this whole thing is longer than this one, they're not congruent to each other. The pieces have a congruent piece because diagonals bisecting each other mean that they cut each other in half. So DB cuts AC into two equal halves, which means that AT is congruent to TC. Okay? But likewise, AC cuts DB in half into two equal halves. So that means that DT is congruent to TB, right? Now we also know some stuff about the angles. It's going to be a little bit harder to put those in here because there's lots of lines and stuff, but let's kind of start there. Okay, so first of all, find the perimeter. Well, the perimeter is the distance out around the outside edge, okay? But again, since we know like these are congruent, then this must be 10, right? And this is 12, then this is 12. So we can find the perimeter by adding all those up, okay? CT, it says is 9, if CT is 9, right? Now, these don't all have to be true at the same time, so, but if this was the case, if TC was 9, well, then we also know that this guy has to be 9 as well, right? Okay? Let's take a look at the angles. CDA, we're talking about the measure of CDA being 60 degrees, CDA. That's this guy, right? And it's the full angle. Now notice there's this other line in here, but we're talking about this full angle right here. It wants us to find CBA. But remember, CBA has to be congruent to ADC or CDA, whatever this angle is, because in a parallelogram, opposite angles are congruent. Okay? So this whole thing's got to be 60 degrees as well. Okay, one more. We got 4x minus 7 for AT, that's this guy, and we got CT is negative x plus 13. Now this is a little tricky because it looks like we both said they were already 9, right? But again, these don't necessarily have to be true at the same time because it has that if part there. So in number 4, we're not going to assume these are both 9 again, but we are going to know that they are congruent to each other. And we know that because the diagonals in a parallelogram bisect each other. So what we could do is we could say 4x minus 7 has to equal negative x plus 13 because bisect means cut into two equal halves. Okay, so that's kind of the setup for those problems. I'm not going to go through the whole thing for you, but I talked through a lot of it, so that should help. Okay, one of the things I wanted to point out though is this guy, justify your answers. Okay, this is not a proof, and I don't expect you to write a whole proof for every problem. But in a proof, every statement has a reason. right? So instead of thinking about this like a full-on proof, just think about each one as one line of a proof. Okay, you got to kind of talk about what's going on here. So for number 1, for example, when I'm looking at this, I would say something like, AD is equal to 10 because opposite sides are congruent in a parallelogram. AB is equal to DC because opposite sides are congruent. And then talk about, adding them all up. So you're going to show your work. You're going to justify your answers. I want you to write out these properties because I want you to practice with them so that you remember them. I gave them to you. You have them. I just, I want you to practice with them. So if you want to use some shorthand, you can do that. I kind of have some shorthand here, some like abbreviations. You just have to add a little bit of extra. So opposite sides, parallel. Now this we can totally tell is for parallelograms because it's in this circle, but if I was writing this out of context, I couldn't just say opposite sides are parallel. I have to talk about opposite sides of a parallelogram are parallel. And so probably how I would write this line is op sides of, and then draw a little parallelogram parallel. Or you could do like op sides of parallelogram are congruent, right? Or something like that. So you can use those short, these abbreviations here as your justifications. That's totally fine. I'm okay with that, right? So like here, I would say measure of angle CBA is equal to 60 degrees. And the reason why would be opposite angles are congruent in a parallelogram. So you would write that out. It also talks about BAD. I don't think we talked about that. But remember that in a parallelogram, opposite angles are congruent, but consecutive angles are supplementary. So if you ignore the diagonals for a second, and you talk about this full angle here and this full angle right here, these guys have to add up to 180. Okay? This one will be congruent to this one, and this full angle would be congruent to this full angle. But any two that are next to each other have to be supplementary. So these add to 180, these add to 180, these add to 180, these add up to 180. Okay? These are congruent, and these are congruent. Talking about angles. Okay, so that's for the parallelogram. All right, let's start talking about the rhombus. Okay? Now remember that rhombuses, or rhombi, which is plural for rhombus, have all the properties of a kite and a parallelogram. Okay? So in our Venn diagram here, rhombus is in the overlap or the intersection of kites and parallelograms. Okay? So it has all these properties, it has all these properties, and it also has 4 congruent sides. Okay? So before I even get started with this, I would just start like kind of labeling some stuff. So this guy, this guy, this guy, this guy, those are all congruent. Okay? In a kite, the diagonals are perpendicular, and a rhombus is a kite, so those guys are perpendicular. In a parallelogram, the diagonals bisect each other, and the rhombus is also a parallelogram. So that means this section, PM, is congruent to this section, MR, right? And this section, SM, is congruent to this section, MQ, right? Those are all things that we know. We also know some things about the angles. Since it's a parallelogram, the opposite angles are going to be congruent. So like this full angle will be congruent to this full angle, and this full angle will be congruent to this full angle. So that's kind of interesting. Another thing we know about kites, this is kind of the tricky one, is that in kites, we have angle bisectors. So like this guy right here, it actually bisects these two angles, or sorry, it bisects this angle, this full angle, which means that this guy and this guy are congruent. We also have this bisected, okay, which means that this guy and this guy are congruent. So this full angle is not congruent to this full angle. You can see that they're different. However, this section of this angle is congruent to this section of this angle. And this section of this full angle is congruent to this section of this full angle. So the little pieces are half, or they're congruent to each other. They're half of the full angle. All right, and that's actually, what's going on here as well. So when you see this guy, this PSM, right, PSM, whatever this guy is right here, this is going to be the same angle on this side because this line is going to bisect it. Okay, so that's kind of a important idea. And then we talk about SPQ. Remember that this guy has to be congruent to this guy. But also, because it's a parallelogram, this full angle and this full angle have to be supplementary. They have to add up to 180, just like in the parallelogram. So remember that a rhombus is a parallelogram and a kite. So not only do we have, opposite angles opposite angles congruent, we also have this line bisects this angle, and so these two sections are congruent to each other, and these two sections are congruent to each other. Okay, so that's going to kind of help you set up some stuff in there. Also remember that the diagonals are perpendicular, so that will help you on number 8 as well. So that's kind of the information you need to know. I'll let you kind of set up and solve the rest of this. And remember, the ifs don't necessarily apply to the next one. So in this case, it says PS is the square root of 6. And then in this case, it says PQ is 3x plus 7. But those don't have to be true at the same time. That's just saying if that was the case, then this will happen, right? So these aren't necessarily, you can't necessarily set these equal to each other because they're in two different problems. So, kind of be aware of that. If PS is root 6, then all of these are root 6. So 4 root 6 would be the perimeter. Okay, just gave you a free one. But then in number 6, scratch that, and let's talk about, well, what if PQ was 3x plus 7? Right, 3x plus 7, and QR is negative x plus 17. Well, remember, these have to be congruent to each other because all 4 sides are congruent. So we can set an equation, we can set these equal to each other and solve for x. Okay, 9 through 12. So it looks like a rectangle. Doesn't say though, just says quadrilateral. So we can't take anything for granted here. Okay, so if WX is equal to YZ, WX, YZ, so if these are congruent, does this thing have to be a rectangle? Okay, so think about that one. I'm not going to answer that one for you, but I think you can kind of figure that one out. Okay, think about what it takes for things to be a rectangle. Are there any other shapes besides rectangles where you would have opposite sides that are congruent? And if you think about that, I think you'll get that one. Okay, 10 talks about, again, an if WZY is a right angle. Now again, we're assuming that this is no longer true. So if this is just a right angle on its own, and that's all that we have, do we have to have a rectangle here? Okay. Again, we don't know anything about the other sides. We don't know if they're parallel. We don't know if they're congruent. So ignore this thing that we already made. Okay, we just have a quadrilateral with one right angle. Does it have to be a rectangle? Okay. And then, you want to explain why on those. Okay, now 11 says, okay, now let's say that those things are both true. Let's say you have opposite sides here and you have a right angle. Okay, if that's the case, does it have to be a rectangle? So again, you're going to have to think through, if that's possible, what other shapes have opposite sides that are congruent, and put that right angle there. Are you able to do that? Okay, so those are slightly different questions. So you'll think about those a little bit. Well, let's look at number 12. So WY, that's going to give me a diagonal. Okay, so it's saying that is equal to 15. And then WZ is 9. And it wants us to find YZ and XZ, right? So this one's a little bit different. This one's I think we have to make an assumption here. We have to to assume that in this case this is a right angle. So in number 12, I know this is a little bit tricky, but again, let's kind of assume, let's make those assumptions. I know that wasn't super clear. I actually didn't make this worksheet, I borrowed it, and I think it's pretty good, but I wanted to clarify a few things, which is why I'm doing this. So if we had this right triangle here, in order to find this side, we could use the Pythagorean theorem, right? So you could use Pythagorean theorem to find that missing side. Now what's going to happen is you're going to have another guy, xz, right? Now if you think about it, if this was a rectangle, which you made a conjecture about probably in number 11, then this guy and this guy would have to be the same, because in a rectangle, remember that the diagonals are congruent. This is a congruent symbol, it's just kind of small. All right, so if you said that this was a rectangle in number 11, then you can kind of assume that these guys are going to be congruent, diagonals are congruent. So that will kind of help you on that one. Okay, now this one we're going to need some help with. I neglected to go over this property in class, but a really important idea that you're going to have is on page 441. There's a theorem there, and there's also an example that you'll see. So let's take a look at that together really quick. Okay, so this is the theorem we're talking about, and it talks about a median. And a median is a line that is created by making a midpoint. So if you look at AD, E is the midpoint of AD. It's halfway in between A and D. And F is the midpoint of BC. And if you connect the midpoints on both sides, you get what's called a median. Okay, so that line, that middle line there, is a median, and it's like halfway between D and A and B and C. Okay, so that's what's called a median. Now what they're saying here is you have the top of this trapezoid and the bottom of this trapezoid, and if you average the top and the bottom, you get the length of the middle. So the length of the middle is the average of the length of the top and the length of the bottom. And that's what this says here. So if you think about averaging something, you add them together and then you divide by 2, or you add them together and then you like half them. So if I take the length of AB and I add it to DC and then I half it or divide by 2, I get the length of EF. That's what this is saying. If you want to see an example with that, 4A is a pretty good example. And again, this is on page 441. And I, again, neglected to talk about that in class as a property of trapezoids. But you're going to need that here. Okay, so let's kind of break this down. Okay, we know it's a trapezoid, which means we know it has exactly one pair of parallel sides, right? So those are parallel. We also know that like this distance, this is a median, so it's like a midpoint between this line and this line. So I think it's pretty safe to assume that these guys are all parallel here. Because the median, it's going to have to be parallel to the top and the bottom. Okay, so it starts by talking about angles. So we got EDC, which is this guy, and then we got AEF. Okay, so we're talking about this angle and this angle. Okay, what do we know about those angles? There's a special name for those angles, and if I were to draw a picture, it might maybe help shake that loose. Okay, so if you think about angle 1 and angle 2, these guys are in the same position in two different intersections. So they're both, this is in the top right of this intersection, and this guy's in the top right of this intersection. There's a special word for that, those kinds of angles, and there's actually also a theorem that we talked about, or postulate about those two angles. So you're going to have to think about those two angles and what they're called, and what you know about them for number 13. Now remember, on all of these problems, justify your answer. Okay, so we need a theorem, postulate, property, something that's allowing you to say it. I haven't written all those down in this. You're going to need to do that. I'm just kind of giving you some hints here and trying to help you get started. So this is not a complete assignment by any means. This assignment wouldn't get a very good score if I were to turn it in. Okay, so that's kind of where we're going to start. We also got DCB, so DCB, this guy, and we have an angle measure, and then ABC. Okay, now remember, if these guys right here are parallel, which they are because it's a trapezoid, then we know something about these angles. Okay, they're not congruent to each other, I'll give you that hint. But let's go back and let's draw this shape out again. Okay, these angles right here in this shape, 1 and 2, are called consecutive interior angles. Okay, they are not congruent to each other. Now notice those are different. That's different than here, right? These are not in the same position. So this 1 and 2 and this 1 and 2 are different 1s and 2s. This has a different name, not consecutive interior. There's a different name for these. These are consecutive interior, and these guys are not congruent. Okay, there's a special fact about these, and you're going to have to kind of remember, look back, and figure out what that is in order to solve this problem. Okay, but I'll give you the hint again that they're consecutive interior. And there's a fact that we know about those. Okay, these here, I'm not going to give you the name of them, but you can probably make a conjecture about what's true about those angles. So if you apply that here, right, these guys right here, if these two lines are parallel, these are consecutive interior angles as well. So there's a fact that's true about that, and you're going to have to use that fact too with these guys. Okay. Should I just tell you? Would that ruin it? Let me give you a hint, a better hint. If you add these together, you should get a specific number, okay? If you add these two together, you should get a specific number. So if you add this together and this together, if you put those two together, you should get a specific number. They're not congruent to each other. I'll give you that hint. They are not congruent. Okay? All right, let's look at 15. If AB equals 6 and DC equals 10, so this is 6 and this is 10, find EF. This is where we're going to use that idea, that theorem that we just looked up. Okay? The idea here is that the length of EF, if it's a median, is the average of these two numbers. It's the average of this length and this length. Okay? Now remember that 15 and 16 don't have anything to do with each other. So after you are like, all right, I did number 15, you kind of reset and you kind of change the measurements because it says if, right? So if EF is 9 and if DC is 15, what's AB? Okay, so this is a little trickier. It's still the average idea, but if I average AB with DC, I get EF as a result. Okay? So I can't just average these two and get this one. That's not going to work. I'm supposed to average these two to get this. And since I don't know what AB is, I'm going to have to use a variable. Okay? So if I take the length of AB, which I don't know, and I add it to the length of DC, which in this case would be 15, and I multiply that by a half, I'm averaging this length, which I don't know, with this length, which is 15. If I do that, if I average those two lengths, I'm supposed to get 9. Okay, so this is an equation that you can now solve. I'd probably start by distributing this 1/2, or maybe multiplying both sides by 2 or something like that to get rid of that 2. And then you're going to have to solve for AB. Okay, in 15 you can just average the top and the bottom. In 16 you don't have the top and the bottom, so you have to pretend like you're going to average them and you know the result. So you're going to have to set up and solve that equation. Okay, 17 through 20. It's a kite, so let's talk about what we know about kites. Okay, first of all, it has 2 pairs of consecutive congruent sides, or adjacent congruent. So it's not the opposite sides that are congruent. Obviously those aren't congruent. It's the ones that are consecutive or adjacent or next to each other. So those guys are congruent, those guys are congruent. Okay? We also know that the diagonals in a kite are perpendicular. Okay? Again, all these are coming from the properties that we talked about in class, or if you missed class, I talked about these properties in the previous video. Okay? Diagonals are perpendicular, 2 pairs of consecutive sides. I'm just kind of labeling this this kite. Okay. Another thing we know is that these full angles are congruent to each other. Okay, not these ones obviously, because if you look at this full angle, it's much smaller than this full angle. So it has one pair of opposite congruent angles. Okay, and then the other pair of angles, again, these aren't congruent to each other, but this line bisects this angle. So this section of this angle is congruent to this section of this angle. And this section of this angle is congruent to this section of this angle. Okay, so that should help. So XWZ, right? XWZ, we know something about that one and that one. Okay, WZT, we know something about that guy. Sorry, WZT. In this case, it says it's 110 degrees. Now that doesn't look like that's possible for it to be 110 degrees. But let's kind of just see if we can make sense of this. So WZT they're saying is 110, and WXY is 40 degrees. Find ZWX. Okay, that's going to be kind of tricky, and that may be kind of a funky one. Let's see if we can work that out together. It looks like this may be a typo. Okay, so if that's 110, then that has to be 110. That doesn't make any sense at all. And WXY, this is 40 degrees. So if this full angle is 40 degrees, this whole angle is 220 degrees, obviously the numbers are, not really making a whole lot of sense here. But if we were to add those together, we get 262. Okay, now what we know is that all four of the angles of a quadrilateral have to add up to 360. So I already know that this and this together this is 220, excuse me. So 220 plus 40, that's got to be 260, excuse me. Okay, so since all four have to add up to 360, the remainder would be 360 minus 260, which would be 100. So these two angles together have to be 100, but we also know that they are they're congruent to each other. So they have to both be 50, because if you divide 100 by 2 to get two even angles, then these would have to be 50 and this would have to be 50. Okay, that looks like kind of a funky question. So I'm wondering if maybe there's a typo and it looks like the answer key maybe doesn't match up with that one. So I'm wondering if they meant, instead of WZT, they meant WZY. Let's try the problem that way and see if it makes sense. Okay, so let's say it's WZY, and this whole thing is 110. That makes a lot more sense to me. Okay, if that's the case, then 110 and 40 together is going to equal 150. Okay, again, all four angles of the kite have to add up to 360. So if I do 360 and I subtract 150 from that, I'm going to get 210. Okay, so these two angles together have to be 210 to make all four angles 360. But these have to be the same as each other. So if I take 210 and I divide it by 2, I'm going to get 105, which I think is what they're after. So WZT, yeah, that does make sense. This better be WZY. Okay, I'll make a note of that in the assignment description in case you guys get stuck as a typo, because that's kind of weird. But yeah, that's what's going to happen there. Okay, let's move on. So WZ equals 5. Okay, WT equals 4. Okay, find WZ. Well, one of the facts that we know is that these perpendiculars these lines are perpendicular. So this has to be a 90-degree angle, which actually gives us a right triangle where this is 5 and this is 4. And you can use Pythagorean theorem to find this guy. Okay, so that's how you're going to do number 19. Okay, and then in number 20, we got WT equals 4 and TZ equals 3, and they want us to find TX. Oh, and TX is 10, find the perimeter. Okay, so we got, this is getting kind of crowded, so let's, I don't know, maybe we should redraw this. Just going to do a quick sketch here. Okay, so WT is 4. Okay, so that's normal. And then TZ is 3. That's this guy. So 4 and 3. And then TX is 10. Find the perimeter. Now remember, these are right angles. Okay, so Pythagorean theorem to get this guy. These two match. Pythagorean theorem to get this guy. Right? 4 squared plus 10 squared equals hypotenuse squared. But then these two guys match. Add them all up and you should get the perimeter. So you're going to use Pythagorean theorem on this one as well. Okay, you got an answer key here. However, you need to show your work. You need to justify your answers. Okay, you need to write what theorems you're using. So I would probably do this on a separate sheet of paper. Otherwise, you're probably not going to have room to do that. So you got a lot of hints there. You have the idea. You just need to put the pieces together. You need to talk about the properties. You need to go through and solve the equations that we set up. You need to go through and complete, what we've been talking about. But that will help you get started. Okay? All right. Thank you guys for watching. I hope that helps. I'll see you in class soon.